Hello, everyone. Today, we're going to write a simple AI code using Python and the scikit-learn library. We'll implement a basic linear regression model to predict housing prices based on the size of the house. Let's get started. First, let's import the necessary libraries. We'll need NumPy for numerical operations, pandas for data manipulation, and scikit-learn for the machine learning model. Next, let's create some sample data. We'll have a dataset with house sizes and their corresponding prices. Here we defined a dictionary named data. Dictionaries are collections of key-value pairs, where keys are used to access corresponding values. Here, the keys are size and price, and the values are lists containing the sizes and prices of some hypothetical houses. Then we create a pandas data frame named df from the dictionary data defined earlier. A data frame is like a spreadsheet with labeled columns, here size and price, and rows containing the data. In the output, we can see the data frame we created. It shows the size and price information for each house, represented by a row. Now, we'll split the data into features, x, and target, y. Here we create a new variable x by selecting the size column from the data frame df. This essentially creates a separate dataset containing only the size information, features, we want to use for prediction. Then we extract the price column from the data frame df and assign it to the variable y. This represents the target variable we want to predict, house prices. Next, we'll split the data into training and testing sets. We are using the train test split function from scikit-learn to split the data into training and testing sets. X, features, and y, target, are passed as arguments. Test size specifies that 20% of the data will be used for testing and the remaining 80% for training. Random state sets a random seed for splitting the data. This ensures that you get the same split every time you run the code, making results reproducible. Now, let's create and train our linear regression model. Here we first create an instance of the linear regression class, which represents our linear regression model. And then we call the fit method on the model, passing the training data xtrain, features, and ytrain, target, as arguments. This process involves finding the best fit line through the training data points. With the model trained, we can make predictions on the test data. To predict the corresponding target values, we call the predict method on the trained model, passing the x-test data as an argument. This method uses the learned model to predict the corresponding target values, house prices, for the testing data. We also print the predicted values. The output shows the estimated house price based on the model's learning from the training data. It represents the predicted house price for the single test instance in your dataset. Since our x-test dataset contains only one sample, due to the test size is 20%, the predict method call returns a single predicted value. The value we got is the predicted house price based on the input features, size, of the test sample. This prediction is made using the linear regression model we trained on the training data. Finally, let's evaluate the model's performance using mean squared error. This mean squared error function calculates the mean squared error, MSE, between the actual target values, y-test, and the predicted values, y-pred. MSE is a metric used to evaluate the performance of a regression model. It measures the average squared difference between the predicted values from the model and the actual values from the test data. The output shows the mean squared error of our linear regression model. A lower MSE indicates better model performance. The high value of MSE indicates that there is a significant difference between the predicted and actual house prices in your test data. This suggests that the model might not be accurately capturing the relationship between house size and price in the dataset. If you want to improve the model, you could try feature engineering, adding more relevant features or transforming existing ones. Or adjust model parameters. Experiment with different hyperparameters of the linear regression model. You can also use a different model. Explore other regression algorithms like polynomial regression or decision trees. And that's it. We've successfully implemented a simple linear regression model to predict housing prices based on the size of the house. Thank you for watching, and don't forget to like, share, and subscribe for more coding tutorials.